Section 1.5, Patterns and Relationships in Tables. Now this sounds scary, or it sounds something that's going to be difficult, but you guys have done something like this before. And I do believe that you called it input and output machines. Basically, a number goes in to the machine, and then a number comes out of the machine, and whatever's gone on in the machine is your expression. It's basically, what are you doing to the variable to get the number in the end? An input and an output machine takes a number in, and then it spits a number out, and then it uses an expression to do that. You did them in grade 6 in math, so we're going to do a quick refresher here. In this case, the expression is 4n minus 2. The input is the number that is being substituted for n, and 4n minus 2 is what is happening to the number in the input-output machine. The output, this is what has happened to n. This is what has happened to the number that went in. So if I put 1 into the input-out machine over here, it's going to go through the expression 4n minus 2, and it will come out as something different. Well, 4n minus 2, if I substitute the 1 in, that's 4 times 1 minus 2. 4 times 1 is 4, minus 2 is 2. Okay? Now, the next number, if I substitute 2, and I put 2 into the input-output machine, 4 times 2 is 8, minus 2 is 6. And the same thing again. 3 goes in. Substitute the n for 3. 4 times 3 minus 2 is 10. If I went to the next number, 4 substitutes in for the n. 4 times 4 is 16, minus 2 is 14. And the last one, 5 is what n represents. 5 in for n. 4 times 5 is 20, minus 2 is 18. The input is your n, or your variable, and the relationship is your output expression. Now sometimes what is being done to the input to make the output number? In this case, we've had an input-output machine. We've put in a 1, and we've multiplied it or added it or subtracted it or divided it, whichever combination. We've done something to our n to make 8. And then we put 2 in, and the output was 11. 3, 14. 4 was the input, 17 was the output. 5 was the input, 20 was the output. Now you might be able to look at the 1 and say, well, I added 7. And yes, 1 plus 7 equals 8. But if I do the same thing to the next one, 2 plus 7 does not equal 11. 3 plus 7 does not equal 10. And I can't multiply it by 8 because 1 times 8, yeah, that's 8. But 2 times 8 is not 11. So something's going on here from each section to section. So I'm going to show you a little trick here to help you out. What you do is you look at the jump in your output numbers. So I jumped from 8 to 11, and then I jumped from 11 to 14, and then I jumped from 14 to 17, and then I jumped from 17 to 20. And all of these numbers are all going up by 3. All of them. 8 plus 3 is 11, 11 plus 3 is 14, 14 plus 3 is 17, and 17 plus 3 is 20. Whatever your jump is here automatically becomes what you're multiplying your input by. So if I'm going up by 3s, the beginning of my expression is 3n automatically. And then from there, you have to add or subtract to make up the rest of your expression. So if it's 3n to start, 3 times 1 is 3, and that's not quite big enough. 2, what do I have to do to that? Well, 3 times 1 is 3. I have to add 5 more to make that so. So now let's check. 1 goes in there. 3 times 1 is 3, plus 5 is 8. If I substituted 2, 2 times 3 is 6, plus 5 is 11. That one worked. Substitute 3. 3 times 3 is 9, plus 5 is 14. So my jump here was up by 3 each time. When that happens, I automatically multiply my variable by that number, and wherever I end up, I have to add or subtract to finish it off. So the actual number is 3n plus 5, so that worked out correctly here. If we jump back to the last page, if we had all these numbers showing and we didn't know our expression, you can see that these are all jumping by 4. 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. 14 plus 18. 14 plus 4 is 18. These are going up by 1s. These are going up by 4s. So that automatically is what I multiply my variable by. And if you look, it is 4 times n. So 4 times 1 is 4, and then I had to subtract 2 to get to here. 4 times 2 is 8. Subtract 2 is 6. So whatever you're jumping by, as long as your inputs go up 1, 2, 3, 4, 5, whatever your outputs jump by is what you automatically multiply your variable by, and then you add or subtract to make your output. So knowing what we've just gone through, you have 2 parts to this practice question. The first one, I've given you your expression, 5n plus 3, and there's your input and your output. I would like you to fill in the output numbers for each input number. If I put 1 into this input-output machine, what would I end up in my output? The second side, I want you to look at what your outputs are. And I want you to write the expression that goes with this input and output machine. So the first part, you are filling in the output of this input-output machine, and in the second part, you're writing the expression that goes along with it.